Hello, I'm Katie Steele, Southwest Climate Hub Coordinator and Director of the ARID Project at New Mexico State University.
And I'm Tanya Burnett, the Education and Outreach Specialist for the National Drought Mitigation Center at the University of Nebraska in Lincoln.
And I'm Julie Elliott, here today to walk you through the current GrassCast maps for the Southern Plains. I recently retired from the Natural Resources Conservation Service as a rangeland management specialist.
Great, we look forward to hearing the updates, Julie. Let's start off with Katie giving a quick overview of the 3-month outlook from the National Weather Service.
Thanks, Tanya. Yeah, so the reason we want to look at the National Weather Service maps before we look at GrassCast is the National Weather Service maps help us to interpret what's going to happen with precipitation over the growing season. So let me just share my screen and then you should pop up. Are we seeing this okay? Yeah. So if you want to find these maps for yourself, just Google the National Weather Service and 3 months outlooks. And the 3 months outlook should be the first thing that appears in your Google search. So I'm just going to bring up the precipitation map. This is the precipitation map that was created, or rather issued, on June 15th, 2023, and it's valid for July, August, and September, so the main part of the growing season. Okay, so the seasonal precipitation outlook for the Southern Plains region, except for, say, Kansas and a little bit of the Southern Plains region in Oklahoma, is really just giving us equal chances of above or below average precipitation. So when it comes to interpreting our GrassCast maps, this might point us to the normal conditions because we've got no indication whether or not we're going to get higher or lower precipitation over the growing season. So the other thing that we should think about when we're working with GrassCast is the temperature, because temperature drives evapotranspiration. Now, these look quite different. So if you look at the temperature outlook for the Southern Plains area, so focusing in here on southeastern Colorado, the Oklahoma Panhandle, southwestern Kansas, eastern New Mexico, and far west Texas, for the northern part of this particular region here in this peach and orange color, that's indicating that we've got about a 33 to 50% chance of above normal temperatures, but this is just leaning above. So it's not necessarily set in stone according to the models that predict the seasonal temperatures. When we get further south, however, into southeastern New Mexico and far west Texas, we're in this sort of deep orange, blood orange color. And that's indicating a 50 to 60% chance of above average temperatures for the growing season. So again, bear in mind what's going on with temperature when you are also interpreting precipitation for GrassCast. So back to Julie now for the real meat of this presentation. And Julie, let us learn how GrassCast works.
Thank you. GrassCast takes information about soils and plant communities growing there and combines them with information with precipitation and temperature conditions from last fall, winter and growing season information to date to create a current soil water profile. The model then adds in future potential growing conditions of above, near, or below normal to simulate grass growth through the end of the growing season into each of the 3 scenarios to create this total production prediction.
So Julie, how does GrassCast actually come up with the potential future conditions?
Good question. GrassCast takes 38 years of precipitation records on the Great Plains, and then it stacks them up with the wettest year at the top and the bottom, or driest year at the bottom. And it uses those top third then to calculate the potential production in a wet year. And the bottom third years are used to calculate the potential production for a dry year. And then those middle years represent the normal or average conditions and resulting growth.
So I've heard that the maps are actually represented in grid cells. So I took a look at what those actually mean. It just means that each area in the map is represented by a rectangular area. And Julie, can you remind me of the area each grid cell covers?
It's 6 miles or 6 miles, or if you're in a metric person, it's 10 kilometers by 10 kilometers.
So in each area, you can't get any finer resolution than 6 miles by 6 miles, but that should give you a fair indication of what's going on at your location, right?
Exactly.
So I have a question.
Sure.
Are the maps showing how much grass is expected?
Not exactly, Tanya. They're showing the difference between the total grass growth expected this year and total grass growth expected in a normal year. The legend is titled percent, and meaning percent of normal. So the blue hues down here at the bottom are 5 to more than 30% or more total grass production than normal. The yellow hues and red hues here at the top of the legend are 5 to more than 50% or 5 to more than 30% less total grass production than normal. And then green is right there, right in the middle, near normal.
So say I'm looking at the map and my area where I'm located is blue. Does that mean I can graze more livestock and expect great conditions for wildlife?
Not quite so fast, Katie. No one has gone to every grid cell in the Great Plains to see what is actually on the ground. GrassCast is a model. It's built on expected plant community makeup and health. GrassCast doesn't know what kinds of plants are currently growing in any particular location. It doesn't know what kind of management it's had. It doesn't know what plants are actually growing there in any particular location. Were the plants grazed short? Or were they left fairly tall? GrassCast doesn't know if the winter snows were captured or if they all blew into the road ditch. It doesn't know if the spring rains soaked in or if they ran off. The model has no way of knowing if your pasture has desirable or tasty plants for the animals or if it's covered in weeds.
So you're saying GrassCast can help someone see the potential, but it really needs to be used with knowledge of on-the-ground actual conditions and management history, right?
Exactly. As a landowner or manager, I have to honestly assess if I've done a good job of managing my land. If the plant species out there are the best ones it can have, and if the water stayed on the land or if it ran or blew off. If so, then I can look at blue on the map, especially the below normal map, and feel pretty confident that I'm in good shape. In contrast, though, if I see yellow or red, particularly in above or near normal conditions, then I need to say, I got to keep a close eye on the pastures and probably get my drought plan in motion. If, on the other hand, I left my range grasses pretty short and I have lots of weedy species, or I can see that the water is just running off my pastures, or if I've been planting fence posts and I know that my fence post holes are dry, then I should be really cautious about getting excited about any blue on any map. If I see yellow or red, I should definitely cause me to implement my drought plan. We do want to keep in mind too, ladies, that GrassCast is total production, not the percent that goes into an animal's belly. So if your rangeland has both tasty and not tasty plants, the tasty ones may drop off first, increasing your grazing loss. I'll go into more details about this later. Just as a quick local example, my maps are showing above average production in my area, but I can tell you what, a lot of that production is going to be made up of cheatgrass, which is fine until it starts to head out, but it's certainly not going to feed any animals in July.
Good points, Julie. Thank you for that. So with that background, we'll take a look at the maps now. And if you're listening and want to look at them in real time, if you go to grasscast.unl.edu, that will take you to the current maps that are available for your area. And there is also an archive of maps on this website. So over to you, Julie.
All right. So when you open the website, all three maps will be visible with above average conditions on the left-hand side, near average conditions in the middle map, and below average conditions represented on the right-hand map. Now, there are lots of colors here, and it can seem just pretty darn overwhelming. So please don't panic or shut down. I'm going to walk you through taking these maps apart so that they're meaningful. We will start on the optimistic side of continued above average rainfall for the rest of the growing season. So GrassCast is pretty optimistic here, isn't it? There's lots of blue. There are some areas of Oklahoma here and Colorado, and quite a few in Kansas and quite a few in Kansas where GrassCast expects at best near normal production. Now remember, we're looking at above average conditions, and GrassCast is saying, you might pull off normal. So those folks in Meade and several counties in northern part of Kansas, which is technically probably not Southern Plains, but particularly Trego County, GrassCast suggests that they can even see significant grass production losses, even if the summer is wet. Folks in New Mexico, Texas, and Colorado, that they may notice that there's some areas here that this funny color, it's a neutral color that isn't on the legend. Well, that's because the statistical relationships between precipitation, plant water use, and the resulting plant growth are too poor to make a forecast with any acceptable level of confidence. We want to remember too that GrassCast only works for grass-dominated landscapes. It does not work in a tree or shrub-dominated landscape.
What happens with average or normal conditions for the rest of the summer?
Watch closely as I change this slide. There's still a lot of country in the blue hues, but suddenly my eyes anyway pick up significant yellow and even orange areas. This southeast corner of New Mexico and across to Andrews County in Texas, here above or near normal total production outlook is not very secure. There's other isolated areas in Texas, such as in here, Oklahoma, Colorado, and southern Kansas, who also lose that optimistic outlook in near normal conditions. Since the northern part of Kansas was already showing troubles, even above average outlook, none of us, I'm sure, are surprised to see that near normal expands those trouble areas.
So looking at these, I fear what the below normal outlook is going to show.
Yeah, Katie, it's not pretty at all. Ooh, the expected loss in total production in the southeast corner of New Mexico expands significantly and then grows a tail into parts of Texas, into the central part of Texas, and even up heading into Oklahoma. Much more of the Oklahoma area and Kansas are projected to see significant losses represented by this yellow, and there's some expansion of loss into Colorado. Notably, this panhandle area of Texas and the border area of New Mexico, as well as parts of Colorado, are projected to see above average production, even with below average precipitation for the rest of the year. This is really significant projection for these folks if they have healthy rangelands and if they can respond to the great conditions so far this year. So remember to use the legend over here to see how this corresponds, what your area corresponds with the percent loss compared to normal production for your area.
Great, thanks for showing us those. Is it possible for me to get more detailed information about my 6 mile by 6 mile grid cell, or do I just estimate off these maps?
No, the great thing is that GrassCast does have a zoomable map feature. You go onto the website and you click this button here, GrassCast Zoomable Maps. Now you need to be patient because it may take a bit for that to load, especially if you've got a little slower internet speed. Going to click on the map and then drag it to keep your area in view, and then just use these plus or minus signs or roll the wheel on your mouse if that's how you like to zoom to scroll into your area of interest. Then click on the map and a pop-up box will appear. You can see that I've scrolled down just past the beginning of this map so that we can of the pop-up box so that we can see the text that I'm wanting to talk about. So now these are the May 31st maps as we're recording this video before the June 13 map were posted. So for this grid cell that I selected here in New Mexico, you can see that in above average conditions, why GrassCast was expecting 11% more production than the area's long-term average. In near normal conditions, GrassCast showed a 9% less production than the area's 36-year average. And on the right-hand side, in a below normal projection, GrassCast says I might expect 35% less than this area's long-term average. So I've got a range of 11% more to 35% less, although two of the maps are projecting some level of loss for me. So then if I scroll this pop-up box down a little farther, grab this bar and pull it down, then I can get some more significant information. Here we can see that GrassCast is assuming that my grid cells had 5.35 inches and that my long-term average for this time of year is 6.16 inches. Remember, this was May 31st. So I need to ask myself, does this seem reasonable? Have I gotten about 5 inches of rain? And do I think that my long-term average is about 6 inches of rain by this time of year? Then I look at the rest of the information. The map is assuming for the above average projection that I'm going to get 8.37 more inches of rain for the rest of the season. Near normal is another 6 inches, and below normal is about half of that, just a little over 3 inches. So I can ask myself, given the pattern that I've seen, given my time out on this property, what do I think is reasonable? What do I think I might expect to actually happen this year? And lean a little more towards those maps to inform my decisions. Remembering that two of the maps are showing some kind of loss. So we're going to have just great conditions to stay in the blue area.
Thanks, Julie. Learning about these pop-out boxes really puts more context into interpreting GrassCast. It's really helpful. So I know on the landing page, there's Southwest radio button. Perhaps you could explain a bit more about that?
Yeah, just briefly. The Southwest covers all of New Mexico and Arizona. So those of you in Eastern New Mexico, you have to decide, do I have a continuous growing season from spring until fall, which was represented in the Great Plains map? Or do you have two distinct growing seasons? One that starts in the spring, runs April through May, and it's really driven on conditions that were received over the winter until the end of May. And then there's a hard stop for this bimodal or two growing season pattern that's seen in the Southwest that starts the beginning of June and runs through to September. And it's based on precipitation and temperatures from June to August. So you want to think about those of you in Eastern New Mexico, you have to decide which maps better represent your rangeland. Do you have a continuous growing season, or do you have this distinctive spring and then summer growing seasons? Arizona, Western New Mexico, you tend to follow this more two distinct growing seasons driven by two different sets of information.
Because the June 13th forecast maps are the first ones for the Southwest summer growing season, they have really little data behind them. So we'll have a separate Southwest video that looks at the summer outlook for the Southwest, starting with the June 27th maps. Julie, do you have any closing thoughts for us?
Well, I did promise at the beginning of the video that I would dive into total production that GrassCast is mapping versus grazable production, or that part of the growth that actually goes into the animal's belly. So let's say, I'm sure we're all familiar with the take half, leave half concept. So let's say in an average year that you have 1,000 pounds per acre. That's what you would expect. And that's what GrassCast is building against for our above or below average production. Well, if we're going to leave half of it, that means we need to leave 500 pounds on the ground. And this is really solidly scientifically backed up. That amount needs to be left out there to protect the soil community, to protect the plant community, protect the microbes that are out there, to prevent erosion. So we really need to leave that 500 pounds of production out there on the ground. So that means we can take half, right? Well, you do take half, but all of it doesn't go into the belly. The animals are out there walking around. So some of that grass gets trampled, they lay on it, they urinate and defecate on it. So then they're not going to eat those plants. So really, we should be figuring that we're going to take about a quarter of the total production, or 250 pounds. So let's say GrassCast says we're going to have a drought, and we should project, or we should expect 30% less production than in an average year. That means we have 700 pounds per acre. But now let's stop and pause here. If we need to leave 500 pounds out there to protect the rangeland, to maintain the plant community, to keep the soils in place, to make sure the water stays there, if we need 500 pounds out there to protect the rangeland in a normal year, don't we still need 500 pounds left out there in a drought year? Maybe even more so. So that means we have 200 pounds left to take. The animals are still out there walking around, trampling, urinating, and defecating on those grasses. So really, we should be figuring about 100 pounds getting into the belly. So now we're comparing 100 pounds into an animal's belly versus 200 pounds in an average year. And I don't have to tell you that that's a whole lot more than a 30% loss. In fact, it's a 60% grazing loss. It's not the 30% total production loss that GrassCast is projecting. So we need to make sure to remember that GrassCast is talking about total production, not what actually gets into an animal's belly.
Thanks, Julie. This really puts it into perspective how important it is to plan when we're expecting drought. And hopefully GrassCast can be a really good contributing tool to helping people make those decisions. So with that, I'd like to thank Julie and my fellow presenter, Tanya. And to encourage you, if you're watching, to check out the introductory video and how to read the map links on the website for more information about the GrassCast maps. Thanks again, everybody.
Thank you.
Thank you.